Hi everyone, welcome to a new session from Treblle, and today we're going to talk about 7 key lessons on building great APIs. Before we get started, I'd like to introduce myself so you know who's talking to you and explaining some of these things. So my name is Vedran. I'm the founder and CEO of Treblle. I'm also an engineer at heart. So in my lifetime, I've probably built more than 100 APIs. So I've seen all the good and bad things that come from APIs. I've got more than 13 years of experience in building APIs specifically. And in the last 4 years, I've actually been selling API solutions and developing API solutions for companies and organizations all around the world, especially with Treblle. Now, I am passionate about 3 things: APIs, IPAs, and barbecue. Sometimes in that exact order, sometimes in a slightly different order. So before we dive into the content and some of the tips and tricks that I'm going to share about learning what makes a good API good, I want to share a bit about Treblle and what are some of the things that we do. So the first thing, what does Treblle do? So simply put, we help organizations figure out their APIs. We like to say that we're an API intelligence platform, and we've got a suite of products, starting with observability, intelligence, security, governance, analytics, documentation, testing, compliance, and a lot more. We were founded in July of 2021. We support more than 25 different programming languages and gateways, which means that from one single platform, you can actually get all the information about your entire API landscape in one simple and easy to use product. Now, we have more than 175,000 API professionals that trust Treblle every single month with more than 3 billion API requests on our public cloud platform. We do, of course, offer private cloud or even on-prem deployments, so you can have a peace of mind when it comes to data privacy and security of your organizational data. But we have a lot of customers in all sectors and all industries with a strong focus on financial, banking, and insurance industries. Not only do customers love Treblle, but also analysts. So you'll see us mentioned in more than 20 different research pieces by Gartner, IDC, Everest Group, and a lot more. We even won an award for Best in API Observability at the API World Conference in Santa Clara at the end of 2024. So now that we've learned a bit more about Treblle, we can actually dive deeper into the fundamentals of building good APIs. Now, before we start, this is one of those things where, given that REST isn't a standard, everything I'm about to say is definitely only a recommendation, but based on more than 15,000 APIs, more than half a billion endpoints that we see in Treblle, here are the best tips and tricks that we think make a good API really, really good and help your organization make money and onboard customers faster through a really great API. The first thing, the first category that I want to talk about is essentially design. So when you think about design, there are a lot of things that are involved when you build an API. But there are a couple of things that are universally applicable across whatever you're doing, across any app, any API, any product that you're essentially doing. The first thing that's very important to remember, that semantics matter, right? So this is one of those areas where most companies get this wrong, and every single person who's ever integrated or built an API knows that essentially you should use nouns instead of verbs and plurals instead of singular. What does that mean? So instead of using something like, let's say, the endpoint name, get users, you should just name it users, right? Why? Because you can reuse that same name across the entire lifecycle of that resource. What does that mean? If you're doing a post request and creating a users, you can still call the endpoint name users, you could just use a different HTTP method called post. If you're getting users or a list of users, you can still reuse that same name because, again, you're making a GET request to users. If you're, let's say, want to update a particular user, you can still reuse the same name because, essentially, you could just prepend an ID or a UUID at the end of that name. So, essentially, you can use the same endpoint name across multiple different resource objectives if you use nouns. Now, when it comes to plurals, the explanation is actually quite the same. So if I named my resource user, if I was to make a GET request to user, it would imply that I want to get a single user instead of all the users in the database. Hence, again, using plural makes much more sense down the line and makes your naming pattern much more consistent when you're building these different resources. This is especially important if you have a really large and complex API. If you stick to the naming conventions and follow nouns in plural, everybody else who's implementing this API or integrating it will be able to understand that there is a certain pattern, and they'll be able to follow that, and they'll expect that to happen across multiple different resources. Now, of course, another area that I think a surprising amount of companies and individuals can make a lot of mistakes is with the improper usage of HTTP methods. Now, HTTP has a couple of different methods. The most popular ones are get, post, put, patch, delete. There's also some other ones, but mostly we're going to focus on those. And each of these methods has a specific meaning. So if I see a method called get users, I am immediately thinking in my head, I want to get a list of users. Again, if you simply prepend a ID at the end of that, so get users / ID, I am expecting to get one single user. That is what all developers and a lot of people are used to, as well as a lot of AI agents. So if you're building these APIs, it's very important to follow a certain set of standards to make your API understandable, not just to humans, but also to AI agents or AI LLMs. Now, why is it important to use each method properly? Well, again, get mostly for getting data. We've kind of crossed that over. Post is for storing data, meaning whenever you see a post request, you're immediately thinking, hey, I want to store some data, or I will be creating a new object there. Again, put and patch are essentially for updating data, and there is a difference. If you want to do a complete update or a replacement, you would use put. If you want to do a small correction on the data or a subset of data, you would use patch. And again, delete, the name implies it. You are implying that you want to delete data. So it's so simple, but yet so powerful. And a lot of companies don't get this wrong. So there's no need, for example, to name these endpoints incorrectly or to use different HTTP methods incorrectly, because that will only lead to confusion, not just for developers, but also other machines like AI agents and LLMs. Another area that is often forgot is the response codes. Now, if you think about response codes, you can think of them as a shortcut to explaining what you meant in any language in the world. What do I mean by that? Well, everybody in the world understands that when I return a 500 on my API, that means an internal server error. Or if I, for example, return anything in the 400 range, that implies a client error. Again, this is something that is built into the core mechanism of the HTTP, or the way that the web works, and we should take advantage of that and essentially not have to recreate our own kind of language or our own way of returning error messages or commands. All you need to do is properly indicate to your customer which response code you want. And a lot of clients, a lot of SDKs, a lot of HTTP libraries will actually handle that correctly. So for example, if you're using one of the HTTP libraries in PHP, as soon as you return a 500, that will throw an exception. So that way, you and your engineers don't actually have to worry a lot about these different things. Now, the last thing that I want to mention when it comes to design is versioning. A lot of people overthink this. And they want to stay away from that because they think it is too complicated and it's too confusing, and with time it gets out of control, especially managing that, and then nobody uses versioning. Well, versioning is one of those things that you should definitely include at the beginning of every API. It doesn't have to be complicated. You can start early, start simple, and always use it. Why? I've been in so many situations, and so have many of our customers, where they essentially didn't have a versioned API. They had critical updates or changes they wanted to deliver, and that API was directly connected to all the clients, like mobile apps, like smart watches or TVs or other devices. And they actually weren't able to do that because, again, it would break or destroy or impact all of those clients. So they had to completely release a new API, new updates, new everything. If they were using versioning, they could literally separate and isolate that single change if they wanted to onto another version, and nothing would have happened. So versioning, even though it might impact the development a bit more, it will certainly ensure that there is less risk down the road for you, your team, and your entire organization whenever you need to do something. So I would say that versioning gives you the flexibility that you need to essentially rapidly innovate and develop across the API lifecycle. So now that we've covered the design perspective of the APIs, we can move into another very sensitive topic, which is, of course, security. So security, I think, is one of the most talked about disciplines or areas of any application or even API development. And based on the data that we have, it is still largely misunderstood, and people largely miss the very basics of API security. And they go and try to overcomplicate, overcompensate, and yet they fail on the basics. So we're going to cover some of the basic things that you could actually do today with your team to build a much more secure API. So one of the core things is, at the beginning of every API, you should use HTTPS or Secure Transfer Protocol. It's completely free, easy way to kickstart your API security. Why? Well, it's very simple. When you're using HTTPS, all the communication between your applications or customers and your API is encrypted, right? That means that nobody can snoop in on that information, and you're inherently much more secure because all the communication that is being relayed through these HTTP servers is encrypted. And who wouldn't want encryption in a world where today it is completely free and you can get it on most cloud providers? Now, a lot of our customers tell us, hey, we are not going to use, we're not going to use HTTPS on internal APIs. Yes, that might make sense, but I still think that is wrong. If you force that discipline, then with time, everybody who's building and shipping and maintaining these APIs will be used to the fact that, hey, we need HTTPS. It's a part of something that we do and not a part of something that we quickly do before we go to production. A lot of these APIs that you develop internally quickly grow and spin out of control, where essentially today they're internal, tomorrow they become partner, and 3 days from now they might become public. So don't kind of be a part of that problem where you now need to do more work before you're taking it to your partners or public, simply start by implementing the HTTPS or secure protocol at the beginning. And in case you're not, that's okay. We have data that shows that 52%, believe it or not, of people don't use an HTTPS connection with their APIs. And that's why we're strongly advising that, above all, this is something that you could do literally today. The next really weird thing or misconceptions that we see is a lot of APIs choose to not use any authentication on their APIs. Again, the justification is this is an internal API. Nobody knows about it. That is the beginning of every article on the internet that talks about leaked data, exposed API keys, or something like that. So use any form of authentication on your API. It could be as simple as a hard-coded bearer token, or as complicated as automatically expiring and refreshing tokens, or JSON web tokens, or something like that. Use anything. Anything is better than nothing. Why? Well, let's use an analogy. I'm sure you all have some kind of an apartment or a house or somewhere where you live, and I'm sure you have windows and you have doors. And I'm sure those doors have a key. And I can't just walk into your house or apartment and, open the door and randomly drink milk out of your refrigerator or something like that, because you have a key, right? Because you control who gets in and who gets out. And you should apply that same principle to the API, because more often than not, you will be in a situation where somebody else might impact your security. Somebody else might have a problem, a security issue that might impact you, and you want to be able to isolate that. The best way to isolate that is by using any type of authentication, because you can literally punish only that customer or only that API key, isolate him, segregate him, do whatever you want. And the next thing that I think a lot of people overlook is, the data that goes through from the customer to the API and then the database, right? And a lot of people forget to validate and sanitize the data before they actually pass it to the API. This means that when you think about an API, its kind of main job is to communicate with the database. And the database is at the heart of your organization, your company. It's where all the value is. So essentially, you want to make sure that the data that's getting sent to the database is as clean, as safe as possible. So the way to do that is, of course, you can validate that on the and sanitize on the API side, which you should above all do. But you can also shift that left and essentially start doing that on the client or the customer side. Now, you're not always going to be able to do that, but if you start there and then do another validation and sanitization process on the API side itself, the database will always remain clean and safe from any malicious inputs, any malicious data, and you will be you'll be exposed to less and less risk. The last thing that I want to kind of emphasize is the headers. So I know a lot of people overlook the headers because it's just one of those things that is on an API that exists, and people kind of know about it, have heard about it, but nobody actually knows what goes on there. So headers are really, really important for a lot of APIs, especially REST-based APIs, because especially if you're running a public or a partner API, because they can usually expose a lot of sensitive data. What does that mean? So a lot of headers can tell me about the technology that you're using. So, for example, there are headers that I can understand and see that you're using, for example, Amazon Web Services or Cloudflare, or even a specific version of a programming language, like, for example, PHP, or a specific version of the web server, or something like Apache or Nginx or something like that. These identifiers of these softwares and vendors are actually turned on by default, right? So if you today spin up a server and launch an API and you're using Apache, the default header will tell me exactly what version of Apache you're using. So if I'm an attacker, if I'm a bad guy, I just need to go and visit one of your API endpoints. I don't even have to authenticate, and I'll have access to all of that information. That allows me to narrow down on the attack vector and how I need to basically attack you and your API, and how can I get the data. You can clean this up in a very easy way and remove any sensitive and non-mandatory headers. So leave things like, content types, accept headers, but anything that is related to software versions, anything that is related to vendor, remove that. You will be much, much better off, and you will make somebody else's job much more complicated. Now that we've covered security, we can move to performance. So with performance, I like to start off with one very important caveat that, again, for some reason, a lot of people fail to apply, and that is caching. So I like to say that caching is key to success on both the server and client side. And whenever you actually see and feel a really fast API, it's because they're using caching. Whatever kind of database technology you're using, whatever connection you're using, everything is much more faster if the data is cached. And when I say both client and server side, that means if your API is making connections or queries to the database, you should cache them. When you're returning a response for a GET request, you should cache that. You should not only cache that on the server side, but also on the client side, because not a lot of applications actually need real-time access to the data. So imagine, let's say you have a banking app and you're loading a list of recent transactions. Unless you're a billionaire, most likely you're not going to be making transactions every minute. So that means that the data that you get right this second can be cached at least for 10 seconds. And then your API reduces the amount of API requests that it's making. It reduces the amount of queries that the database is making, and so on and so forth. So not only are you increasing performance, but you're also saving money on infrastructure costs. So again, very easy to implement. There are many great caching solutions out of the box, things like Redis, things like DynamoDB. All of these things make it super, super easy to basically cache a lot of this data. Now, the next area, again, a lot of times overlooked, is pagination. Now, you're thinking, well, why are you even mentioning this, Vedran? Because you wouldn't believe how many times I've seen APIs or endpoints that are returning thousands of records, right? Without any particular good reason. It's just because, it was the easiest thing to do. It was much more complicated to paginate data, get the client to implement pagination, and so on and so forth. So if you implement pagination, again, you are reducing the load on your database. You're reducing the load on your infrastructure. You're making the entire journey faster and smaller for the customer, because there's less data that needs to be transmitted from point A to point B. And it's very easy to implement. A lot of programming languages, a lot of tools have pagination built in, and you shouldn't return a large data set unless you actually really, really have to. Now, the last thing, the third thing actually is about database. So whenever people actually complain, hey, my API is slow, 9 out of 10 times, that actually translates to the database is slow or a query is slow. So if you truly want to increase the performance of your API, you need to look at your database connections and your database performance. Again, a lot of that can be done with caching, but you should look at how you're structuring this data, how you're storing this data, and of course, how you're getting this data. This is where, again, you will need to do a deep dive into a lot of this. Probably you won't be able to do it yourself, but essentially, this is where you will uncover a lot of the benefits and a lot of the performance improvements, especially over time. I've seen and personally have worked on APIs where the initial, for example, performance was horrible, up to like 5 seconds of load time on an average endpoint. As soon as we implement the database, as soon as we optimized the database, as soon as we implemented caching, that went down below 1 second. So, and it took us only a couple of days to do that. So that is tremendous results and impacts from those two things. The last thing that, again, is so simple and powerful, yet so overlooked, is compression. So a lot of web servers nowadays have the ability to compress data while it's being sent to the customer. And the most popular ones being gzip compression, broadleaf compression, deflate compression, zlib compression. These are all different compression libraries that are available to you today on your current existing infrastructure. All you actually need to do is either turn it on or return a header to indicate that you are actually compressing this data. So this is something where you can go from a payload size of, let's say, 500 kilobytes to a payload size of 50 kilobytes. The compression ratios of some of these compression algorithms is up to 80-90%. So if all you need to do is enable one header and your data, the amount of data that you send between the customer and your API will be reduced by 90%. I think everybody wants that. So you can actually go ahead and do that today without any complications or not a lot of development hours required. The next kind of category when we think about building really good APIs is the documentation. Now, one thing that is really important here is I fundamentally believe that if you do a really good job on the design part, where you're naming endpoints properly, you're naming your parameters properly, you're following a certain pattern that is easy to understand and guess, your API documentation or the job that you have to do here is going to be much more easier. So a couple of things on documentation is, when you're explaining things to somebody, try to be as descriptive as possible with your endpoints and the data that need to be sent, meaning properly label what is required, what is optional, what data types can go in here, what data options are there, because that kind of allows me as a person who's integrating your API to self-service a lot of my own questions. Because if you think about an API, the person who's integrating it doesn't know anything about it. I'm coming to your API with no kind of insights into it. I need to understand everything that there is, and the more information there is on the documentation, the less questions I'll have. And the more information there is, the more comfortable I'll be with the API, and the more easier my job will be, right? So describe things as much as you can. And again, documentation starts with great design. So everything that we said in the first slide about design applies right here. The second thing is about examples. So provide request and response examples, because that's how most people learn. If you think about even myself and yourself, you probably learned a lot of things in your life by doing or by seeing. You see, somebody in your you see somebody fixing something and now you learn how to do it. You see or hear somebody talking another language, you pick up on it, right? That's what most people want to see in documentation, an example of a request. That's the first thing I personally look for as well. I just want to see how that's done. Show me the data. I want to see what you're sending. I want to see how the response is being returned and all of these different things. The next one is use standards for writing and reading documentation. This is something that I think should be a solved thing at this point, but you should use Open API specification as much as possible because it is a de facto standard of building and writing API documentation. And if you have an Open API spec, you can basically build any developer portal with ease. You could have any AI or agent or AI LLM understand and read and parse through that data. Any client can convert that Open API spec into an SDK or into code. Tools like Trebble's Alfred can actually understand the Open API specification and generate entire SDKs, answer customer questions about the API and the documentation, and essentially drive the integration and adoption of that API much more faster. So that's why it's very important to use something like the Open API specification, which again, you don't in most cases need to even write specification. Nowadays, you could get an Open API spec representation of your API just by using Treblle or any other tool out there. And I think the most important thing about documentation is provide context when things go wrong. A lot of people like to say, hey, if I document everything thoroughly, if I make everything great, nothing will ever go wrong. That's definitely not the case. And 90% of time, something will go wrong. And your job as the API producer is to help your customers understand what do they need to do next. Again, this comes back to design and properly labeling, these response codes with if I'm a client making a request on your API, I'm not sending the correct fields. You should return something on the 400 range or something like that, but essentially provide as much details as you can. Right? Hey, you're not sending the first name field. You're not sending the email field. It's not a valid field. A lot more context goes a lot further when it comes to understanding the APIs. The next categories, and I promise will be done fast, is adoption. So if you've built a great API, now you need to get people to use it. And one of the easiest way to get distribution for your APIs is build as many SDKs as possible to make the adoption process be as seamless as possible. So engineers specifically like really good SDKs, especially when it's publicly available on GitHub and, more importantly, regularly maintained. So a lot of engineers will actually proactively go on your GitHub page and they'll try to figure out, do you have SDKs? If you do, when was the last time they were updated? Do you have one SDK or multiple SDK for the language that they need? You can also use a lot of tooling to build SDKs automatically and keep them updated automatically. Again, you have tools like Trebble's Alfred that essentially generates integration code, the SDKs, whatever you want, based off of the Open API spec file. But this is one of those things where it's almost like a checkbox for a lot of these engineers. Do they have good documentation? Yes. Do they have SDKs? No. Something might be wrong here. Why wouldn't they have an SDK? Do I need to build one, etc., etc.? So build SDKs. The next one, I think, there's a misconception about the amount of and the level of support you need to provide when you're dealing with an API integration. You have to be ready to provide support in every step of the way, and a lot of the times this includes a lot of technical support. So people who are integrating your API are most likely engineers, right? It might be an AI agent soon, but today you're dealing with a bunch of engineers, and a lot of times they have questions, they have problems. It's really hard to get started with an API and get onboarded. So be ready to provide support in a very meaningful way, and that might be a lot of technical support. Again, this is where you can utilize a lot of tooling like Treble's Alfred or something like similar that essentially helps you ease that pain. But this is not something that you can avoid regardless of how good or bad your API is, how good or bad your API documentation is. Because at the end of the day, there's an unspoken truth about engineers is they don't read anything, right? So they'll probably have a million questions and you need to be ready to answer them. Now, another kind of tick box is engineers expect to see beautiful developer portals or else they'll go away, literally. And this is something that as an engineer, I also kind of I'm guilty of, but when we go to a website, especially an API documentation website, I expect to see a top-notch product, a top-notch developer experience. If I don't, I actually think something might be wrong here. So try to provide a great developer experience, because if you do that, your life will be much easier. You will get the customers faster. You will get people to integrate your API faster, and everything in between. And the last thing is simplify onboarding time and make it extremely easy to get to a first request. And I think this is really important. It is crucial to get to that first request as soon as possible, because that kind of gives everybody a perception of how much time they're going to lose integrating your API. If you make that super complicated, if there's an account that I need to create with like 20 different fields, I'm not going to do that. Create a sandbox environment. Let me make a request. Let me see how it works. Let me see the performance. Let me see the response code. Let me see how I can use that in my own business logic. And then I will go further and invest more time into properly onboarding on your API. This is something really important. This is where a lot of people actually fail and lose a lot of integrations. Now, the next one is something that we hear a lot of our customers are doing this year, and especially relevant when we live in this age of AI agents, LLMs accessing a lot of data, accessing a lot of APIs without actually understanding what is going on. So governance is one of those things that you're eventually going to start doing if you have multiple different APIs, and your API landscape is, I would say, bigger than 20 to 30 APIs. This is where you need to basically define a set of standards for your APIs and stick to them at every step of the way. This is probably the most difficult thing for most companies, because it means that your engineers need to follow a certain set of rules when you're building APIs. And nobody likes rules. Nobody likes rules imposed on them, but there are ways that you can actually approach this in a dramatically better way. So the first thing that you can do is implement a centralized API versioning strategy that everybody can follow. Establish an API review and approval process that doesn't suck. And above all, educate people on building great REST-based APIs. So content like this really goes a long way. And furthermore, there are tools. Again, we have a tool, it's called API governance, where we can automate a lot of these checks. So the reason why most organizations fail is because it's a lot of manual work to check for quality, for performance, for design standards on these APIs. And using software and tooling like Treblle, you can automate this entire process. In Treblle, we actually give you a unique score across 3 categories that you can easily understand how good or bad this API is. What's even more important, we give tooling and shift governance left to the engineers, where we have a VS Code extension that can help them understand how are they measuring up against both industry standards and best practices, as well as your own custom rules. A lot of people also adopt rules from bigger companies like Microsoft, GitHub, Adobe, all of these have a certain style guide and a certain pattern when they're building APIs, and you can easily start analyzing how they're doing that and easily start comparing where you fit as an API. The last and by far not least is monetization. So this is one of those things where everybody is kind of interested in and everybody is talking about, but I don't think a lot of people have figured out how to do this effectively. I think there are traditionally companies that have been built on top of APIs. So companies like Stripe, companies like Salesforce, companies even like Amazon. All of these companies are essentially early adopters of APIs as product and early proof point that API monetization is possible at scale. So there are a couple of tips or 4 that we've identified working with a lot of customers who make a lot of money on APIs. The first thing is have a free tier so that any engineer can easily get started and implement your API. I've talked about this in a couple of slides before when we were talking about adoption. But essentially, try to offer a sandbox environment where I can quickly access that and get at least mock data or mock responses and easily fiddle around with the API, see how it feels, like we like to say in engineering, see how it fits into our processes, and essentially build on top of that. If you truly want to unlock APIs as a product or monetization, you need to be ready and you need to have technical and business support throughout the entire process, because just like any other product, this is a sales process at the end of the day, and you are selling something except it's an API. And you should, at every step of the way, optimize everything to speed up the first time to request, like we've mentioned, because essentially that will have a direct impact whether or not that person wants to do business with you. If it takes me a very long time to onboard onto your API or make that first API request, I'm going to think that you are slow as a company, and you definitely don't want that to happen. And last thing, be predictable around pricing models where customers have a lot of control, meaning a lot of people like to do usage-based pricing, which is great, but I don't want to lose a lot of control. So I would rather pay for a bracket or a bulk or a batch of API requests and not have to worry, will I go overboard? Will you charge me 3 times more if I go, etc., etc. So providing clear, transparent pricing that I can, to a degree, control is something that most customers that we talk to actually like. So that brings us to an end of everything that I wanted to cover in this lesson, and hopefully you managed to learn something new. To end it here, you have my contact details right here. You can reach out to me via email, via phone, via even letters, if you will, or an API request. But essentially, all of these problems at its core are, to a degree, very easy to solve if you just put some time into it with proper tooling. And again, please, I invite you to check out what we're doing at Treblle. You can solve these pain points a lot more easier, because we live in a very exciting time where again, a lot of these things can be automated. A lot of these things can be done without manual work. And again, the end result will be much more better for everybody, because if you build truly great APIs, you will end up making more money, onboarding more customers, and essentially bringing more value to your shareholders. So thank you so much for following along. And again, if you have any follow-up questions, I would be more than happy to answer. Thank you.